Hello, we're going to solve radical equations. It's a truly radical experience. Not really, but it is different, as you'll see, and it can be pretty interesting. Here we are. We are going to solve this equation, and you're going to see that you've got the same basic steps every time. So maybe it won't be that interesting. Considering that to math teachers, interesting can mean difficult, yeah, it would be nice to have boring math problems. Well, anyway, I need to make this bigger. There. And what I want to do is I want to isolate that quadratic term, quadratic square root term. Okay, so that means I'm going to subtract 10 and subtract 10 from both sides of the equation so I can get the square root all by itself. 10 minus 10 is 0, so I'm left with the square root of 5x equals 17 minus 10 is 7. And now here's something that might be new to you. We have to get the x out from underneath the radical, right? And since it's with the 5x, we have to get both of them out. So I'm going to square the left side of this equation and square the right side of the equation. And that will give me 5x without the radical, without the square root sign, and 7 squared is 49. Now to solve for x, all I have to do is divide by 5 and divide by 5. And we're done. The answer is x equals 49 over 5. And put it in a little blue box. Piece of cake, right? Well, let's check this out a little more closely. Let's solve this equation. The x plus 2 is a binomial that is underneath the radicals, so this is all one radical term here. We have a radical term equals -10, so let's square both sides. Boom, boom, square, boom, boom, square. Now squaring a square root takes the radical off, so we have x plus 2 equals 100. -10 times -10 is 100. Now I subtract 2 and subtract 2. So I have x equals 98. Now I wish I could say that was correct. It's not really. Yes, and that's going to be a problem with all of these. You have to check your answer because you can get something called an extraneous solution. Extraneous means extra. An extra solution that is not the solution to the original problem. I'll show you, I'll prove it. The square root of x plus 2 equals -10. Now, if x is really 98, I'll put 98 plus 2 in here, and I'll get negative 10. So I'll have the square root of 100 equals negative 10. So 10, the square root of 100 is 10, equals negative 10. Is that true? No, it's not. This is false. So this is extraneous. It's not the real answer. In fact, this problem has no answer. The only correct answer is no solution. But you don't know until you check the problem. You're going to have to check all of your solutions. It's just the way it is in radical equations. Let's check this. The square root of 5x plus 10 equals 17. Okay, I'm going to put a fraction in here. 49 over 5, but I have a 5 out here that I'm going to write as 5 over 1. And multiply these two, and in the process of multiplying, the 5s will cancel. So I'm left with the square root of 49 plus 10 equals 17. The square root of 49 is 7 plus 10 equals 17, and that's true. 17 does equal 17. So this is the solution. 49/5 is the solution. The problem with radical equations is you never know. You never know when you've got an extraneous answer and when you don't. So you always have to check your answers. I did everything right down here, and I still got an extraneous answer. Now, we move on. My square root is already isolated, so I'm going to square the left side of the equation and the right side of the equation. When I square the left side of the equation, I get x minus 4 times x minus 4. Don't be fooled and say x squared minus 16 or x squared plus 16. You have to do this. However, when you square a square root, you get what's called the argument, what's underneath the radical, x minus 2. Now, let's multiply this. We'll get x squared minus 4x minus 4x plus 16 equals x minus 2. Minus 4x, that's minus 8x. So we have x squared minus 8x plus 16 equals x minus 2. Now this is a quadratic equation. So that means I have to use the zero principle. I'm going to subtract x from both sides of the equation, and I'm going to add 2 to both sides of the equation. Over here, I get 0 plus 0, which is, yeah, it's 0. Over here, I'll get x squared minus 9x plus 18. So x squared minus 9x plus 18 equals 0. Now this is a quadratic equation, and so far the only method you've got for solving a quadratic trinomial is factoring. Luckily, our leading coefficient is 1. So we get to use an easier method than grouping, and that always makes me happy. X. Now 18, negative 6 times negative 3 will add together. Let me finish my sentence there. To give me negative 9. So minus 6 minus 3. And then I set each factor equal to 0 and solve for x. Let me scroll this up. Add 6 to both sides. I'll have x equals 6. Add 3 to both sides. I'll get x equals 3. So you want to say that x equals 6 and 3. But this is a radical equation, and you just don't know. Here are your possibilities. 6 and 3 might both be solutions of the equation. Or 6 and 3 might both be extraneous. I've seen it happen. Or 6 might be a solution and 3 might be extraneous, or the other way around, 3 might be the solution and 6 might be extraneous. You don't know. So we're going to find out. X minus 4 equals the square root of x minus 2. Okay, that's true. And x minus 4 equals the square root of x minus 2. Now this is how I'm going to check my answer. This side I'm going to let be x equals 6, and I'm going to let this side be x equals 3. Okay, so 6 minus 4 equals the square root of 6 minus 2. 6 minus 4 is 2. The square root of 6 minus 2 is the square root of 4. The square root of 4 is 2, so we have 2 equals 2, which is true. That means 6 is a solution. Now let's come over here and check. X equals 3. 3 minus 4 equals the square root of 3 minus 2. 3 minus 4 is negative 1, equals the square root of 3 minus 2 is positive 1, and the square root of positive 1 is 1. So we have negative 1 equals positive 1, which is not true. In fact, it's false. They're two different numbers, which means X equals 3 is extraneous. So what you're going to do is you're going to have X equals and an answer box. You're not going to put in two answers, 6 and 3. You're just going to type in the number 6. That's it. This is the only solution. 3 is extraneous. Always check your answers. Okay, here we have another equation. The square root of x plus 7 plus 5 equals x. I need to isolate my square root, so I'll subtract 5 from both sides of the equation. That gives me the square root of x plus 7 equals x minus 5. Then I need to get the radical off of the x, which here is paired with an x plus 7. It's part of a binomial, so they're stuck together. At least under the radical, okay? Yeah, the only way to free up the x is to square the square root. So I'll have the square root of x plus 7 squared equals x minus 5 squared. The square root of x plus 7 squared is just x plus 7. X minus 5 squared is x minus 5 times x minus 5. So x plus 7 equals x squared minus 5x minus 5x plus 25. So x plus 7 equals x squared minus 10x plus 25. This is a quadratic equation, so I set these guys to 0 and move them over here. Minus x, minus x, minus 7, minus 7. Here we'll have 0 plus 0. Over here we'll have x squared minus 11x plus 18. So 0 equals x squared minus 11x plus 18. Now, I've got a 1 leading coefficient, so I make empty parentheses. Don't have my coffee with me. X 18 equals -9 times -2, and -9 plus -2 is -11. So -9 and -2. So, yes, okay. So there are my factors. -9 plus -2 is -11. -9 times -2 is +18. Now I set each factor equal to 0. You know all about that. I usually only need 3 lines. X minus 9 equals 0. X minus 2 equals 0. Plus 9, plus 9. -9 plus 9 is 0. So X now is by itself equals 9. And over here, plus 2, plus 2, X equals 2. Now we have to check the answers. So I have to go up here. Okay. Write down the original equation. The square root of x plus 7 plus 5 equals x, and the square root of x plus 7 plus 5 equals x. And I'll use this side for x equals 9, and this side for x equals 2. And then I'll scroll up so I can see what I'm doing. And you can too. All right, if 9 is x, this is what I do. 9 plus 7, square root of 9 plus 7, plus 5 equals 9. And over here, the square root of 2 plus 7 plus 5 equals 2. Okay, the square root of 9 plus 7, that's 16. The square root of 16 plus 5 equals 9. The square root of 16 is 4, so 4 plus 5 equals 9, and it does. 9 equals 9. So this is true. 9 is a solution. Now let's come over here and try the 2. The square root of 9 plus 5 equals 2. Square root of 9 is 3. 3 plus 5 equals 2. 8 equals 2. No, it doesn't. That's false. And that means x equals 2 is extraneous. Oh. U-S. Notice that the first 5 letters of extraneous they spell extra. That's what extraneous means. Anytime you square both sides of an equation, you're in danger of getting an extraneous solution. So you have to be very careful and check your answer. Okay. Here's another one. X minus 4 equals the square root of 28 minus 4x. My radical is already isolated, so I'll just square both sides of this equation. That gives me x minus 4 times x minus 4 on the left, and 28 minus 4x on the right. So over here, I'm going to have x squared minus 4x minus 4x plus 16. And on the right, I have 28 minus 4x. So I'll combine these two terms. I take away 4 x's, I take away another 4 x's, that means I've taken away 8 x's. X squared minus 8x plus 16 equals 28 minus 4x. All right, it's a quadratic equation. I have to use the zero principle. Minus 28 minus 28 plus 4x plus 4x. On the right, that gives me 0 plus 0, which is 0. On the left, I have x squared minus 4x. I took away 8 x's, then I put 4 of them back, meaning I'm only 4 x's down now. So minus 4x, and 16 minus 28. Ew. Okay. It's late. It's late as I do this. 16 minus 28. Negative 12, so minus 12. So x squared minus 4x minus 12 equals 0. And again, I factor, with 1 being my leading coefficient. Boom, 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 boom equals 0. X, now let's see, negative 12 equals negative 6 times positive 2. And negative 6 plus positive 2 is negative 4. Okay, so we're going to use negative 6 and positive 2. X minus 6 equals 0. x plus 2 equals 0. Or on the left, add 6 to both sides. X equals 6. On the right, subtract 2 from both sides. X equals -2. And now we're going to check our answers. X minus 4 equals 28 minus 4x. Square root of. Let me make sure that's correct. So 28 minus 4x. Okay. And x minus 4 equals the square root of 28 minus 4x. So we'll have x equals 6 and x equals -2. X equals 6. 6 minus 4 equals the square root of 28 minus 4 times 6. And over here, -2 minus 4 equals the square root of 28 minus 4 times -2. Okay, come over here, 6 minus 4 is 2, equals the square root of 28 minus 24. So 2 equals the square root of 4, and the square root of 4 is 2. So that means that 6 is a solution. Now, -2 minus 4 is -6. Square root of 28 minus 4 times -2, that would be a +8. So -6 equals the square root of 36. -6 equals the square root of 36, which is 6, and that's false. So x equals -2 is extraneous. Is extraneous. Is extraneous. So this is what you put in your blue box. Only the real solution. Not the extraneous. Though there are some questions that ask you, what is the solution? Is there an extraneous answer? And if so, what is it? Aha, and now here we are. We've got a couple of word problems. Applications. This formula right here is used by the police to find out if a wreck is your fault. So any of you who plan to go into criminal justice, you're going to know that by heart. Of course, a computer gives you the answer. But R equals 2 times the square root of 5L. Now this can be used to approximate the speed r. So r is the speed. In miles per hour of a car that has left skid marks of length L in feet. Skid marks. Oh, that just brought back such bad memories to me. Oh well, we overcome. How far will a car skid at 50 miles per hour? Okay. That's the answer, but you don't really see it. R equals 2 times the square root of 5L. So 50 miles per hour equals 2 times the square root of 5L. Now, something we're going to be doing a lot of is this number 2. This number 2 right there is not under the radical. Therefore, we can divide it over to the other side. Divide by 2, divide by 2. 50 divided by 2 is 25. 2 over 2 is 1, so it becomes invisible, and we'll have the square root of 5L. Now we square both sides. $25 squared equals the square root of 5L squared. 25 squared is 625. $25 gets squared a lot in math. This will be 5L. Remember, when you square a square root, you just get what's underneath. Now I'm going to divide by 5 and divide by 5. Now, 625 divided by 5 is 125. And that's how far your car is going to skid if you're going the speed limit, below the speed limit. If you're out on 102 in front of the college and you're going 45, I mean, it's posted 45 miles an hour, but everybody goes 50, 60, 70. Well, if you're going 50 and you have to hit your brakes, you're going to go another 125 feet. Smash! And then there'll come the police with their little measuring stuff. Just make sure you weren't smoking or drinking or doing something worse. Let's go to pendulums. Here's a pendulum. It swings to the left, swings to the right. We're going to be talking about the period of a pendulum. The period is, you take your pendulum and you pull it over here and you let it go. So it swings over here and then it swings back. Let me do it with this. You pull it over here, You let it go, it swings as far as it can over here, and then swings as far as it can over here. That is 1 period. You let the pendulum go, and it swings, and when it comes back to where it started, not down here, but to where you started it, that is 1 full period. T is the letter, because it's time, T is the letter for the time of a period, of a pendulum. So this is, yeah, let's write period over here. Okay, and let's read what this stuff is. The formula T equals 2 pi times the square root of L over 32 can be used to find the period T in seconds of a pendulum of length L in feet. What is the length of the pendulum that has period 2.8 seconds? And it tells you to use 3.14 for pi. Okay, so the period is in seconds. And the length of the wire that's in feet. So it's a big pendulum. Not a little pendulum like this. So this is going to be in feet. And this will be in seconds. Now, they're telling us that the length of a pendulum, the period is 2.8 seconds. Okay, we've got T equals 2 pi times the square root of L over 32. Now this is not as hard as it looks. Be calm. So T is going to be 2.8 equals 2 times 3.14 times L over 32. So 2.8 equals 6.28 times the square root of L over 32. Let me make absolutely sure that I've got that right. Yeah, square root of L over 32. Now, I divide both sides by 6.28. 6.28. So we're going to have 2.8. Don't put it in your calculator yet, because every time you use your calculator, you build up a little more error every time. Error. You build up enough, you'll get the wrong answer, and my math lab will tell you, oh, sorry. You don't want that. So what we're going to do is this. I'm going to put parentheses around this and square it, and parentheses around this and square it. But I'm not going to put that in the calculator yet. I will. I promise. 2.8 over 6.28 squared equals L over 32. Now I'm going to be solving for L. So that means I'm going to multiply both sides of this equation by 32. Boom, boom, leaving me with L. What L equals is 32 times 2.8 over 6.28, parentheses closed, squared. Now, before I put that in the calculator, I want to find out how many round to the nearest hundredth. The nearest hundredth is 2 decimal places. So let's write that down. 2 decimal places. Okay, now I am ready to use my calculator. Oops, 32. Okay. Clear. 32 parentheses 2.8 divided by 6.28 close parentheses square. Enter. Now the answer should be 6.36. And it is! Yay! All right, let me do this. I'm going to copy that just so you can see it if you look at the notes. There it is. And then, of course, I am going to make it smaller. There. Okay. Now round to 2 decimal places. I have to, here's the second decimal place, here's the first decimal place. I have to look over at the third decimal place to see if that's big enough to make the 6 round up to a 7. It's not. So I just forget these guys and I go with about 6.36 feet. Because remember, we're finding the length of the pendulum. It's going to be about, or really close to, 6.36 feet. Yes, it is. And that's it. That's it for solving radical square root equations. There are other kinds of radical equations, but in this class, we concentrate on square root equations when we solve radical equations. So, when I come back, we're going to talk about the complex number system. It's a different number system from the one you're used to. It's gonna cause a little mind bending, but you can handle it. Talk to you later. Bye-bye.